Data communication equipment is designed to provide or gather information that often needs to communicate beyond itself to similar equipment. Devices communicate over many different protocols and cables. Some communicate over RS-485 or Modbus R2U protocol. Some communicate over USB, Ethernet, CAN, HART, Ethernet IP, or fiber optic communication. We provide switches, repeaters, converters, and gateways that allow computers, controllers, data acquisition equipment, and other devices to communicate with each other. Today we're going to go over industrial Ethernet, fiber optic, serial, Modbus, USB, DeviceNet, CAN bus, and Profibus switches, converters, and gateway products. Network switches are computer networking devices that join network segments or devices. They take a message from any device connected to it and then transmit it to the device the message is destined for. A hub takes a message and transmits it to all devices on the network. An unmanaged switch allows Ethernet-based devices to communicate with each other and are plug-and-play. Managed switches allow devices to communicate with each other and also allow you to configure and monitor the local area network. We have switches in fire-retardant plastic or metal cases. We have 5 and 8 port versions that have a DIN rail mount. We have switches with up to 24 ports. We also have an NS205 IP67, an IP67 waterproof, dustproof industrial Ethernet switch. Our switches are used in a lot of industrial machinery and in control panels that are in very hot or very cold climates. We also have fiber switches with Ethernet ports, RS-232, 422, 485 to fiber, and CAN to fiber converters. Our NS205 switch meets some vibration and electrical standards. It is very robust and has ESD electrostatic discharged circuit protection. It can operate between temperatures of -30 to 75 Celsius, which is -22 to 167 degrees Fahrenheit. This picture shows how 6 PCs can communicate with each other through an NS208 8-port industrial Ethernet switch. It also shows an i7019R analog input module connected to an i7188E1 serial to Ethernet converter, which is connected to the NS208 switch. Through the switch and serial to Ethernet converter, the serial-based i7019R can also communicate with the PCs on the network. i7188EX serial to Ethernet converters are being used in machine failure data acquisition systems. They allow a barcode device with serial communication to communicate back over Ethernet to a computer. They are networked together with an NS205 industrial Ethernet switch. When the machine stops, an operator can use a barcode scanner to scan the type of stop and the time of production resumption through barcodes. The system shows the duration of stops per type in real time in a graph. It logs the frequency of a given stop over several months. We have multi-mode and single-mode fiber switch options which require different cables. Single mode has a small diametral core for light to go through it, and multi-mode has a large diametral core. Oftentimes, fiber cabling is already installed, so when adding a fiber switch to an application, you need to pick the fiber product that supports the same type of cable. Protocol converters are devices that allow the conversion of one type of protocol into another for interoperability, so different controllers, computers, and devices can communicate. Here's a table that shows our protocol converter and gateway product selection. The X's at the cross-section between the different protocols symbolize the different types of converters we provide. If you look at the HART protocol along the left-hand side, you can see we have a HART to Modbus and a HART to USB converter. Serial device servers allow serial devices to communicate back to computers on Ethernet networks through virtual COM ports. COM ports are real hardware ports on a computer. If a serial device is located far from a computer, but computer networks are present at a location, a serial to Ethernet device server can allow a serial device to communicate back to a computer. A software utility is used to set up the serial device server and allows communication to the serial device as if it was hardwired. A card reader with an RS-232 interface was set outside of the door, far from the central system. By nature of RS-232 communication, data derived from the card reader cannot reach the central system. That's why we need a device server. It allows us to connect the central system to the card reader. And through Ethernet, the problem is solved. Many devices are often installed, like a module and a PLC controlling lights, buttons, and air conditioning. Programmable device servers provide the capability of multi-COM port connections. By nature of Ethernet, we can extend the transmission distance. A programmable device server can easily send local data to a remote control center. PDS features programmability. As you can see, with programming, we can automatically light up rooms when someone is just about to enter. In our device server family, we have DS712. It is equipped with RS-232 and Ethernet ports. This allows direct conversion of data from serial to Ethernet. DS715 is equipped with RS-485, RS-422, and Ethernet ports. Programmable device servers feature programmability and more RS-232, RS-485, and RS-422 COM ports. In addition to that, some members of this family have built-in digital I/O channels for further functionality. As you can see in the table, we have many standard PDS series models. The model name represents the number of COM ports. There are some special types of our PDS. Let's go through them one by one. PDS 742 IP67 is waterproof as well as dustproof. It can connect to 1 RS-485 and 3 RS-232 devices at one time. It can also communicate with a PC by Ethernet. Here is PDS 78225. It's designed for easy wiring. Your RS-232 devices with standard connectors can be easily connected to PDS 78225 with the cable you see here. Never even worry about wiring. PDS 775A is equipped with 7 RS-485 COM ports. It's designed for connecting many RS-485 devices at one time if needed. For further understanding, we have listed a few frequently asked questions here. Are those COM ports isolated from each other? Yes, and every COM port also passes a 4 kilovolt ESD test. Since every COM port is isolated, can I set a different baud rate for each of them? Yes, with VXCOM utility, the packaged software we offer, you can finish configuring the settings in seconds. How many devices can I add onto an RS-485 COM port at one time? You can add up to 256 devices.
We are Modbus users. Does PDS support Modbus Serial and Modbus TCP/IP protocols for communication? Yes!
Serial device servers can be used to help remote kiosk machines like ATM machines or video dispensing machines to communicate back to a control center to provide real-time machine and account status. The PDS 700 are a series of programmable device servers that can also run a C language-based program inside. They can be used with a computer to send, read, and write data. Modbus Gateways can be used to convert Modbus RTU to Modbus TCP, so serial-based Modbus devices like power meters, data acquisition modules, and instrumentation equipment can interface with Ethernet-based Modbus TCP systems. CAN communication equipment can allow non-CAN-based devices to communicate over CAN networks. A CAN communication board can be used in PC to provide CAN communication. I-7530 provides conversion of RS-232 to CAN, so CAN devices can communicate to PAC controllers running SCADA software. I-7540D converts CAN to Ethernet, so laptops can communicate back to CAN networks. RS-485 to CAN converters like GW7433D allow for incorporation of RS-485 devices into CAN networks. PAC controllers like WinPAC, ViewPAC, and XPAC can use CAN communication cartridge modules like I8123W to add CAN communication. CAN I/O racks support a wide range of analog and digital I/O cartridges for use in CAN networks. Ethernet IP was developed by Rockwell Automation, which provides a wide range of controller equipment for industrial automation applications. Ethernet switches and Ethernet cables can be used to network different Ethernet IP devices together. A Modbus RTU device, like TPD430, can be used with an Ethernet IP-based device, like the Compact Logix PLC from Rockwell Automation, through GW7472 Ethernet IP to Modbus RTU converter. Protocol converters help with building on existing applications or with integrating different devices into new applications. I-7520 is an RS-232 to RS-485 converter. It has a DB9 connector on one end and a terminal block with an RS-485 port. RS-485 supports up to 256 modules in one network without a repeater and supports up to 2048 modules in one network with a repeater. RS-485 supports communication distances up to 4,000 feet for up to 256 modules. I-7520 is isolated on the RS-232 side. Other versions are available with isolation on the RS-422 or 485 side. I-7520R is for use only with a PLC instead of a PC. RS-485 is a simple bus that uses two wires for communication. It supports a long cable length, which is ideal for joining many remote devices. It is widely used in many different industries, including railway, machine, and building automation. Industrial USB to RS-232, 422, 485 converters, like I-7561, allow a computer to communicate with serial devices. It has a driver that supports Linux and Microsoft-based operating systems. Isolated RS-485 repeaters, like I-7510, can repeat and strengthen the RS-485 signal for passing on data to other devices like RS-485 to RF converters, like SST2450, or other equipment. Industrial USB to RS-232, 422, 485 converters, like I-7560, allow computers and laptop devices like modems, controllers, and PLCs to communicate to RS-232-based equipment with a DB9 connector. RS-485 networks support up to 256 modules and can communicate up to 4,000 feet without a repeater. With a repeater, they can communicate over greater distances, and more modules can be on the same RS-485 bus. BACnet is a building automation and control networking protocol that was specifically designed around communication needs. We provide BACnet to Modbus converters that include many objects: AI, AO, AV, BI, BO, BV, MSI, MSO, and MSV, and provide flexibility in mapping Modbus registers to any combination of BACnet objects. They can be used to allow integration of Modbus devices like drives, motors, and data acquisition equipment into existing BACnet-based automation systems. CAN protocol is widely used in the automotive industry. Wi-Fi is a convenient and widely used wireless protocol. CAN to Wi-Fi converters like I-7540WF support communication distances up to 100 meters or 328 feet and allow devices like smartphones and laptops to communicate with CAN devices like controllers and data acquisition equipment, which may gather data like pressure or mileage. Wireless communication is especially ideal over wired when working with rotational machinery. CAN switches like I-2534 allow different CAN devices from different CAN networks with different baud rates to be joined together. They allow for extending CAN networks and allow for star or tree network topology. They are widely used in machine, building, and vehicle automation. CAN to fiber converters like I-2532 allow the conversion of CAN to fiber for long-distance communication. Fiber protects against EMI interference and supports transmission distances up to 1.4 kilometers or 0.87 miles. PC cards can be added to PCs for communicating with equipment like modems, PLCs, meters, machine equipment, or programmable automation controllers. PCI communication cards can help with communicating to different devices like printers, card readers, and barcode readers. PCI communication boards can also help with implementing parking structure automation systems. They can allow SCADA software on a computer and data acquisition equipment to keep count of available spaces in a parking structure so drivers can see the number of available spaces before entering the structure.